So welcome back to the Express Tech Tips. Today we're going to talk about the traffic light system, which we discussed last Tuesday, and we're going to look how it is built. So in this case I have the Arduino on the right hand side and the Raspberry Pi on the left hand side. We have the traffic light system working on both Arduino and the Raspberry Pi. I have a push button here, and you see that blue light is lit, and as soon as this LED turns yellow, the blue light will go off. The same with the Raspberry Pi. I press the button, the blue LED is lit, and as soon as with this traffic light the yellow light goes on, the blue light goes off. And we can also see that in the screen with the blue light is on message that when I press the button. For your information, the right hand section is the output of the Arduino, and the bottom section underneath the Raspberry Pi and the Arduino, that is the section for the Raspberry Pi. So how I'm able to turn that blue light on? First of all, in this series I'm gonna show you a simple traffic light, how it is built. And I mentioned that I'm using certain pins, so I will be using that as well. So let me move over to the Arduino sketch program. So this is the program which we're gonna write. As soon as you open a new one, you will see this. Void setup. This is the setup for the Arduino, and void loop, which is your main program. That's what it says here as well. But first we need to define any pins. I mentioned that I'm using pin number 2, 3 and 4 for the bottom section, and 6, 7 and 8 for this traffic light. And for the blue LED I'm using pin 10 and the button is pin 11. So I'm gonna define it here. So we will define pins for the traffic light 1. So here we do a define green 1 for traffic light 1. That will be pin 2. We're gonna do a define yellow 1, which will be pin 3. We're gonna do a define red 1, which will be pin number 4. I'm not gonna do anything with the second traffic light and the button yet, because I want to make it as simple as possible. In the beginning I said I would like to have the traffic light blink. So within this setup, first thing what we need to do, we need to set the pin modes correctly. So pin mode green _1, that will be an output pin. Next thing what we're gonna do is we're gonna make the traffic light a standard traffic light, which means I would like to have a yellow blink with a delay of half a second. So blinking on, blinking off. And the way I have set this up, I use an inverted mode, which means the LED is connected to the positive side, positive rail, and then the pin is connected to ground. The way I'm doing this is to draw as less current from the Arduino. Otherwise the Arduino will provide current, and now it receives current. So to be able to do that, I need to set all pins high to have all LEDs off. So I need to do a digital write of green to high, a digital write of yellow to high, and a digital write of red to high. This way I will reset all LEDs. So let me first check if sketch is correct. So let me put a traffic light 1. Let's name it this way. So it does a check. Oh, I have a failure here, so let's see what this is. Green one, yeah, that's true. It needs to be in capitals. I defined here green in capitals, so throughout the program this needs to be in capitals too. So the same with yellow. Let me see, did I make another mistake? Nope, that's it. Okay, let's try it again. Hey, I forgot you see? I forgot a closing bracket. Do it again. So this is fine. So the old program is still running. So it's compiling the sketch. And it says it's ready, so I'm gonna upload it. And then the traffic light should be cleared. You see, the traffic light is off. So that's the first check to do. So next, what we are going to do is we are going to initialize the traffic light, which means I would need to have the yellow blinking for a certain amount of time. So first things first, so we have a delay of 500 milliseconds. Now I'm gonna do a digital write low. I'm gonna copy, gonna paste it here, and we're gonna do a low. And we can copy and paste this one. Okay. So this will be a high to switch it off. Let me put the following here as a remark. Note, high is LED is off and low equals LED is on. So let's see. Let's do it one more time. So this is one time on, off, on, off. So let me put that down here. So check it, see if that works. So the LEDs are already off here. So it's off. Okay, it ran. So now this LED, the yellow LED, will start blinking. And the last section is off. So next, so this is a simple setup of your Arduino. So next thing to do is write your continuous program. So that would be that the red light on the traffic light will be on. So I'm gonna do a digital write red 1, comma, low. I'm gonna wait 2 seconds. I'm gonna do a digital write red 1 high, which means the LED goes off, and I'm gonna turn the green light on. That will be there for 5 seconds, and then I'm gonna turn the green light off, and I'm gonna turn the yellow light on. Now I'm gonna wait 3 seconds, delay 3 seconds. I'm gonna turn the yellow light off. I don't have to turn the red light on because that's the first statement what is done here. So let's check if everything is okay. Oh, let's see, got this. So now the sketch is okay. Let's upload it, and then we will see the yellow light starts blinking. When it's off, the red turns on, green goes on for 5 seconds, goes into yellow, and then yellow goes off and red. So now it's a continuous program. This is the easy way for a traffic light. So, but let's continue now because I have the push button. over here. At this moment nothing will be happening because it's not defined. So I'm gonna define that push button. So define pins for button and blue light. Define button will be at pin 11. Oh. And the blue light will be on 10. So next, what do we need to do? I need to set the pin modes. So pin mode for the button will be input, and I have configured as a pull up. You can also have a pull down, but in this case it's a pull up, and pin mode for the blue LED will be an output. So that's the initialization, and since the blue light needs to be configured, I'm gonna do digital write blue high, which means the LED is off. Let's check. Looks good. Let's upload it. So I did not configure this button, so let's do that. At least we know that there is no problem in the program. Let's check on the button press. So if a digital read on the button equals low, because that means it's pressed, then I'm gonna do a button press. So I need to light up the blue LED. So I do a digital write blue, comma low. Okay. And I said that as soon as the yellow is turning on, so here I'm gonna turn off the blue LED. Remember, high is off, low is on. So it says here, digital read, if the button is pressed, then the blue LED will go on. So let's see if I made any mistake. Nothing there. Let's upload it. The LED is blinking, turns into red, then green, then it goes to yellow again, it goes into red. I'm pressing the button, but nothing happens. If I keep it pressed, then I might get lucky. So, how are we gonna solve that? Because that's the problem what we have with this script. When I do a delay here, program stops for 2 seconds. And with the 500, program stops for 0.5 seconds. Oh. So this is 5 seconds. And this is 3 seconds. So I didn't introduce the auto traffic light yet. So the program stops. So whenever you press this, you need to press it at the right time. At the time that yellow is gonna put high, just before the red 2 seconds delay, or actually just before that, starts the 2 seconds. So you have a very small window here. Then that button gets detected. Or you need to keep it pressed, but that's not what we want to do. We want to make it a momentarily pushed button to switch on the blue light. So how are we gonna solve that? You can do that at 2 ways. You can use an interrupt, or you're gonna use a check on time, and actually in this case on milliseconds time. So how we're gonna rewrite this program to make it correct, actually to make it the way I would like to have it performed. So let's see if we can make it correct. We know that the button is not functioning correctly. So I'm gonna use, and that's my way of working, a millis check. In the Arduino, we automatically have the millis library installed. So I'm gonna define some statuses. So I'm gonna define 3 statuses, 2 seconds, 3 seconds, and 5 seconds. I'm not gonna worry about the delays which I have put in the setup, but I'm gonna define the 3 intervals. So I'm gonna use a long, and that's an integer, millis interval of 2 seconds. I set it to 2000 because that's an interval test. So, and the 2 stands for 2 seconds. So let me do it this way. Then I have a long 3 seconds and I have an interval for 5 seconds. Now I need to have 2 checks because these are the intervals in between 2 checks. So first of all, I'm gonna do a long current millis. So current millis equals millis. So I'm gonna read the milliseconds currently available and I put it in there. And then I also need a check on the previous millis. And I'm gonna set that to 0 for now. So this is the, let me put it there, millisecond interval checks. So do I need something to do in the setup? Actually, yes, because the setup, I can actually put this to 0 first. Let me do this. So in the setup, at the end of the setup, I'm gonna set the current millis and the previous millis to the same value. So now both are set the same, so we can use that. But we have another issue. How are we gonna check that we have a red LED and a green LED? So I need to have some checks done. So I'm gonna create a traffic light state set. So I'm gonna define a string called traffic light state, and that equals to, in this case, red 1, because that's the first state. So this would be define the traffic light state after initialization. So the traffic light state is red 1. That's the first state after the initialization. So instead of starting a digital write here, I'm gonna do a if traffic light state equals red 1. So if the traffic light is red, then we need to check for the next step. We started here with a digital write on red. That's not the initial traffic light state anymore. So I need to move that up to the last setup line. So now the red light is on. So the traffic light state here, I could actually put this down here as well. Traffic light state is on. So I do a digital write low, the traffic light state is on. So I have a traffic light state red, I have a, let me copy it, traffic light state green, I have a traffic light state yellow. Those are the states. So what happens? Instead of this delay, I'm gonna do a comparison, because at the traffic light state, delay time is 2 seconds. So I'm gonna put a if statement here as well. If the current millis, and I'm gonna subtract the previous millis, is larger than the millis interval of 2 seconds, that will be this minus this. If that's more than 2 seconds, that means the traffic light was on for 2 seconds. I need to go to green. So my traffic light state will be green. But I need to switch off red. So I'm gonna do a digital write. So that's this section. Gonna remove this. Gonna put it over here. So I'm gonna do a digital write. Red high, which means it goes off, and green it goes on. But if it's not yet the difference, then I need to update the current millis. So current millis is again the same as millis. So now this delay is actually what we did here. So the delay is actually this statement here. It checks if there is 2 seconds past to turn green on and red off. And I'm going to change to traffic light state green. So I actually could copy this whole section into here. So now it needs to be, because it goes from green is 5 seconds, so I need to check on 5 seconds. And the traffic light state, if the delay is more than 5 seconds, it goes to yellow. And then the green LED will go off, the yellow will go on, and if the blue LED was on, it will be turned off. So this 5-second delay is now solved by this piece. So I'm gonna get rid of this. So the delay there was 2 seconds for this section, 5 seconds for this section. So we're almost there. So let me do it here as well. So yellow one, that's 3 seconds, and the state will go to red. The next action is yellow will be high, but now so I need to take this one and put it over here. So I need to turn the red light on. So this is yellow, 3 seconds wait. If the 3 seconds have passed, red will be on and yellow goes off. So and that solves this issue. So I didn't change anything here at the bottom, because what happens if this has not been passed, it continues to the next check and to the next check. If it doesn't have to do anything, it continues loops, which means it is really a continuous loop and it doesn't wait. There is no waiting state. So let's see if we did it right. Oh, where is it wrong? Millis interval 5 seconds is not declared. Let me see. I made a mistake here. So let's see. Okay, the sketch is running. Okay, that's fine. Let's upload it. So let's see, it's uploading. We have a blinking yellow. It goes to red, green. Oh, that's something wrong there. You see, all 3 are on. So we made a mistake. I see the mistake. Because what do we need to do? We need to make sure that the previous milliseconds is also updated. So we need to set the previous millis the same as the current millis, so that the next check will be the same. So that's the mistake. We need to update previous millis as well, otherwise previous millis stays in the same time and then all intervals are not working correctly. So let's run the code again. I'm gonna upload it. So let's check. We should have a blinking orange LED or yellow LED. Goes to red, goes to green, then it goes back to yellow, and then it goes back to red. So that was the problem. So, as mentioned, I did not change anything here to the blue button. Press. So let me press it. Hey, the blue light is on. And it turns off when the traffic light is yellow. I'm gonna press it again. And it turns off. Now press it again. It stays on until the yellow LED goes on. Which means if I would like to automate a detection here instead of a push button, then the traffic light would not be interfered, or actually the switch, because this would be a train detection and then a switch will be changed. This traffic light would continue to work. So adding the second traffic light would be easy. Next week we will dive into the programming of the Raspberry Pi so we can see the differences and how it has been created. If you want to see more of these videos, please consider to subscribe to my channel and hit the bell icon to get notified for further videos. Give it a thumbs up and I will see you in a next video. Thank you and goodbye.